Someone has finally used LTX 2.3 to do video face swapping, as the video generation model with the most creative possibilities right now. How could it possibly be missing a face swap feature? Recently, someone released a LoRa specifically designed for LTX 2.3 face swapping. To give you a complete understanding of this LoRa model's pros and cons, we've conducted a comprehensive review across different resolutions, shot types, environmental interferences, scene transitions, and even various ways of writing prompts. What exactly are the strengths and weaknesses of this LoRa model? How can you use it to achieve the absolute best results? I believe that after watching this video, you will definitely find the answers you are looking for. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online workspace because whenever new extensions and models drop, they are always the first to support them. At the same time, Running Hub provides an online community platform for ComfyUI creators. On here, you can find a ton of inspiration and sample workflows. The model we are going to talk about today is an LTX 2.3 LoRa. Its name is Best Face Swap Video. This model has gone through 3 versions in total. The first 2 versions basically use the first frame of the video to maintain character consistency. The third version, however, extends this character consistency from a single image to the entire video, massively improving the overall effect. You can download the corresponding LoRa from their Hugging Face page. They provide 2 models there. You should download the second one. As for how to use this model, they provide very detailed instructions. Here, we need to install an extension called the BFS Node to make this model easier to use. The author developed this ComfyUI extension tool. Its main purpose is to take our reference face image and reference video to generate the final guide video required by the LTX model. They also provided a workflow link, which you can download and use directly. The workflow you are looking at right now is my revised version based on the official release. In the original workflow, there was a lot of content related to prompt generation, utilizing several helper nodes like Alama. Personally, I feel these nodes don't offer a high return on investment for the setup, so I removed them. However, the core mechanics of the workflow remain completely unchanged. Let's break down the core components of the workflow in detail. First is loading the main model. Here, the main model we are using is still provided by Kijai. I need to remind you that Kijai's models are continuously being updated, so try to choose the latest version when selecting your model. There's nothing particularly special about how the model is loaded. The only thing to note is that we loaded the video face swap, LoRa. Following the official recommendation, we set its weight to 1.0. The second part is generating the reference video. The reference video we refer to here is the actual video the LTX 2.3 model uses during sampling. Since the function of our workflow is face swapping, generating this reference video requires a driving video and a face image. First, we need to scale the driving video. Because video face swapping is essentially editing the original video, we cannot set a fixed resolution here. Instead, we only set a base resolution. When scaling, we link the base resolution to both the width and height. This ensures its longest edge matches the base resolution. Also, when using this scale node, you must ensure the final resolution is divisible by 32. Additionally, in this workflow, I didn't specify a total frame count. Instead, I set a duration and used a formula to calculate the total frames. The purpose of doing it this way is to ensure the final generated frame count satisfies the condition of 8n+1. Regarding the face image selection, although there are no strict requirements, to get better face swap results, we highly recommend choosing an image where the face is the absolute main focus. We didn't do any special processing for the face image inside the workflow. To generate the final guide video used for LTX sampling, the most crucial step is using this BFS Node extension. You simply connect your reference video to the frame's input and connect your face image to the face image's input. After passing through this node, you will get a video that looks like this. The overall resolution of this video is identical to the final resolution you set. On the left is your face image, and on the right is the reference video. The left side takes up 255 pixels. The face image is centered with a 12-pixel margin on both the left and right sides, and the background is green. The reference video on the right is also centered, but it uses a black background. Next, let's look at how the guide video influences our sampler. First, we need to design prompts to generate the original positive and negative conditions. Then, we use the LTX conditioning node to inject these conditions into the latent space. The most critical step comes next. We will use the Add Guide multi-node to add the guide video's constraints into the latent space as well. We have introduced this node to you before. It comes from Kijai's Kijai node extension. Pay attention to the inputs here. Besides passing the positive conditions, negative conditions, and the VAE to this node, you also need to pass in our guide video and the VAE coded latent. After that, we can generate new positive conditions, negative conditions, and a new latent. Moving down, we have the sampling process. This is mostly identical to the official ComfyUI sampling process, but you must pay attention to the sigma settings. Here, we didn't use the custom sigma method. Instead, we selected a scheduler and set the sampling steps to 9. After extensive testing, we found that this sampling method works much better. If you use the official custom sigma method, the face often ends up distorted, blurry, or deformed. Many of you might not find this specific scheduler in the drop-down list. If that is the case, you need to install an extension. You can see the GitHub link for this extension right here. The installation is very simple. First, clone this repository into your custom nodes folder. Then install the required Python dependencies, restart ComfyUI, and you will be able to find this scheduler in your drop-down list. After decoding, we get our final face swap video. I need to mention how we handled the audio here. Although we extracted the audio and used methods like setting a latent mask during the process to retain the original audio, we didn't use the decoded audio during the final video synthesis. Instead, we took the original audio and spliced it directly onto our video. The reason is that LTX 2.3's audio processing isn't great, and it always produces some electronic interference noise. Now that we understand the basic structure of the workflow, let's test out the overall face swapping performance. There are actually many factors that influence the final result. The most important and fundamental one is the inherent limitation of the LTX 2.3 model itself. We have done many LTX 2.3 workflows before, especially image-to-video ones, and you might have noticed that LTX 2.3's performance in maintaining character consistency isn't ideal. If we had to score it, it would probably only get about 70 points. Given this characteristic of the model, you will find that all the face-swapped videos will roughly sit at this level of character consistency. With that major premise out of the way, let's look at how other factors affect the face swap. After tons of testing, I believe camera angle is the #1 factor among all variables. By angle, I mean whether the reference video or reference face is a wide, medium, or close-up shot. In this example, we chose a close-up video of a beautiful woman talking. For the face reference image, we picked a standard portrait. Let's look at the final generated result. First, the basic features of the reference face are completely rendered in the final video. Also, the original character's movements are perfectly transferred over to the face swapped video. You need to notice something here. Even subtle actions like facial expressions and lip movements are flawlessly replicated in the generated video. This is something other models simply cannot achieve. If you want ideal face swap results with LTX 2.3, you can use the shot angle selection from this workflow as a reference. The second factor to note is the difference between Eastern and Western facial features. I will use 2 workflows to illustrate this. First, look at this workflow below. We selected Western subjects for both the reference face image and the reference video. Because the angle selection is also highly appropriate, you will see the overall result is absolutely beautiful. As a comparison, let's look at this other workflow. Here, we chose a Western character for the face reference, but an Eastern character for the reference video. Let's look at the final face swap result. Our first impression is that there is a massive discrepancy between the generated video and the reference face. Even if your camera angles for both the face and the video are perfect, if you try swapping faces between characters of different ethnicities, the final result probably won't be great. Next, let's check if scene cuts affect the visuals. Usually, when we choose a reference video for face swapping, we pick a continuous one-take shot without any cuts. But what happens if there is a scene transition? Let's look at this workflow. The reference video shows a girl dancing and there is a camera cut in the middle. Pay attention, during the cut, the character's clothing changes from silver to black. The difference before and after the cut is huge. In this kind of wide shot, you can pick pretty much any face reference since the face occupies very few pixels. Here, we chose an Eastern beauty as the face reference. Let's look at the final result. In terms of the face swap itself, the face doesn't look great. It has a very obvious oily or plastic texture to it. However, the camera cut did not break the face swap process. But there is a surprise. Did you notice that the character's clothing, which changed from black to silver in the original cut, stayed silver the whole time? It remained identical to the clothing before the cut. From this phenomenon, we can conclude that the training dataset did not include multi-character data. So, once the model captures the character's features, it applies them to the entire video without changing them midway. The final factor we tested is environmental interference. The video we chose is quite special. The shot starts underwater, slowly pans up, and finally breaks the surface to reveal the woman's face. This reference video has two characteristics. First, the character's face doesn't appear immediately. Second, there is interference from the water. Let's look at the final face swap result. I think it looks pretty good. To further prove this point, I tested another workflow where the reference video is simply a face entirely underwater. Through this test, we can see that even in extreme environments like this, the face swap effect holds up really well. Finally, let's talk about the impact of prompts on the face swap effect. Regarding how to write prompts, the official team provided a template and a prompt engineering guide. You can use any large language model, input this prompt engineering guide as a system prompt, and upload your control video, the one with the face on the left and the reference video on the right. Doing this will give you a prompt. We paste this prompt into our workflow, and it generates our face swapped video. I tested about 4 or 5 videos, and I personally feel that the impact of the prompt is not obvious at all. My advice is that you don't need to spend too much time and energy writing the perfect prompt. Regarding the LTX 2.3 face swap model, I personally think its character consistency still needs improvement. However, this type of face swap also has many strengths. For instance, the video's colors, lighting, and generalization capabilities are quite strong. If you are aiming for extreme likeness, I suggest you don't use LTX 2.3 for face swapping. But if you are looking at the overall quality of the video, I personally think it is worth a try. Alright, that is all for today. Follow me to become someone who truly understands AI.